Next lesson in this unit is on a notation that's going to help us deal with some very large numbers. It's called factorial notation. You may have seen numbers like this before, a number followed by an exclamation mark. Now, this does not mean that you shout the number 8. What it means is it's a way to calculate 8, 7, 6, 5 times 4, 3 times 2 times 1. You start here at this number and you multiply by one less, by one less, one less, one less, all the way down to times 1. That is a factorial. A couple of special factorials to start us out. 0 factorial is defined to be 1. Why is it 1? Keep watching videos. I will cover that on a later video. It's a better explanation if we do a few other things first. So for the time being, think of this as strictly an invention. 0 factorial is 1. 1 factorial is also 1. It's just 1 times, there's nothing else to multiply by. 2 factorial is 2. 2 times 1. 3 factorial. Now we start to get somewhere. 3 times 2 times 1, and we end up with 6. 4 factorial. 4 times 3 times 2 times 1. 24. And so on and so on and so on. We already saw 8 factorial was 8 times 7 times 6 all the way down to times 1. You can see these are going to get very large very quickly. One other thing about 4 factorial. Notice that this is 3 factorial. So I can say that it's 4 times 3 factorial. A little hint for later. We can use that to simplify some other things. More on that shortly. In general, n factorial, any number factorial, is that number multiplied by 1 less, multiplied by 1 less of that, multiplied by 1 less, and so on, all the way down until you get to times 1. I can also express n factorial as n times this factorial. And the way I would write that would be n minus 1 factorial. Here I have n minus 1, n minus 2, n minus 3, and so on. All of this stuff here is just n minus 1 factorial. And again, this is a simplification technique. You can also say that n factorial is n times n minus 1 times n minus 2 factorial. Let me give you another example to illustrate this. I'll go back to 8 factorial. 8, 7, 6, 5, 4, 3, 2, 1. 8 factorial is also 8 times 7 factorial. It's also 8 times 7 times 6, 5, 4, 3, 2, 1, 6 factorial. And so on, and so on, and so on. Now, what purpose would this have? Well, it is possible that we're going to get some extremely large numbers at some point. Factorials on your calculator are kind of limited. Your calculator will not be able to do every single factorial because it's going to overflow, because the numbers are just way too large. So, let's say, for instance, we have this problem. 86 factorial divided by 84 factorial. 86 factorial is an extremely large number, too big for your calculator. So what I can do is I can say, look, 86, 85 times 84 factorial divided by 84 factorial. And now we can reduce those terms out. Once we get to here, it's 84, 83, 82, 81, all the way down to times 1. Here are those same terms, 84 times 83 times 82, all the way down to times 1. They're just going to cancel out, leaving us with a simple calculation, 86 times 85. That's how you can use factorials to reduce fractions, reduce very large numbers down, and eliminate all those repetitive terms. Before we move on, these are some common myths and mistakes that I have seen people make with factorials. I'll use 15 factorial over 7 factorial, 8 factorial. That does not equal 1. The common mistake here is students see the 7 and the 8 and they think, oh, this is just 15 factorial. No. 15 factorial, 15, 14, 13, on and on and on. 7 factorial, 8 factorial is 7 times 6 times 5 times 1 times 8 times 7 times 6 times 5 times 1. So this is really 7 factorial times another 7 factorial times 8. Nowhere near 15, 14, 13, and so on. They are not the same thing. You do not add these together to get a new factorial. This is all multiplication down here. There is no addition. Another myth. Eight factorial over 12 factorial. Think, oh, I can reduce 8 over 12. I can divide both of them by 4 and get 2 factorial, 3 factorial. No. 8 factorial. All the way down. 12 factorial. All the way down. What ends up happening, if we just leave it as is, all of these terms cancel all of these terms, and you're left with 1 over 12 times 11 times 10 times 9. 1 over a big number. If I look at 2 factorial over 3 factorial, well, 2 factorial is just 2. This is 3 times 2 times 1, gives me 6. I'm saying that 1/3 and 1 over a big number are exactly the same. No. Again, these are all multiplication terms. 8 times 7 times 6 times 5, all the way down. 12, 11, 10, 9, all the way down. We don't simply get to just reduce these and then apply the factorial. Think order of operations. We multiply all these out, then we look to reduce. Or we write out the terms, we reduce all the common factors out, then we multiply. We just cannot take, oh, I can divide both of these by the same number. It's not how it works. This tells us number of factors. Number of factors. It is not itself a reducible number in this case. Third myth. If I see a factorial squared, I'm not allowed to simply say, oh, I just square the number and then have factorial. No. 3 factorial is 3 times 2 times 1. 6. If I square that, I get 36. On the other side, 9 factorial, 9 times 8 times 7 times 6. Big number. 9 factorial is fairly large. It's over 360,000. 362,800. Sorry, 880. 362, 880. Clearly, these are not the same. Now, is it possible to do factorial on your TI graphing calculator? You bet it is. Here's what we're going to do. The math button right here gives you this screen. Going to arrow over to the probability menu, and it's option number 4. Now, if I just do this, factorial, it's going to say take my last answer. Well, let's say I want to do this problem down here. 9 factorial. So I type in the number first. Go to math. I'll use the left arrow to get there faster. Option number 4, 9 factorial, and there it is. That's how we do factorials. And 9 factorial, 9's a fairly small number. Factorial is pretty big. Something like 15 factorial. We're already up to where our calculator says, I can't handle that without using scientific notation. Factorials grow very, very fast because you're always multiplying by one bigger, multiply by one bigger, multiply by one bigger as you go up the chain here. You're always multiplying by one more number, and that number happens to be larger. Factorials get massive quickly. So techniques to reduce them are going to be very helpful to you. Next video, we'll start to get into more of the meat of our unit. This factorial notation, though, is something that's going to come in handy as we move on.